Hey Chan Physics, Mr. Block, and we're just going to do I will see how long of a video this is, on the homework for reading quantitative motion graphs. So the first problem shows a velocity versus time graph. And so that's the key. The last question in this homework is going to be the first answer I give you, and that is, what's the first thing we do when we're trying to look at one of these graphs? We have to figure out what kind of graph we have. And so you guys can see right there that this is a velocity versus time graph. So you got to get your mind in the spot of this is velocity. So it says here, give a written description of the motion without using words like velocity or acceleration. So we go down to the first second. We see that it's a -5 velocity. So the first question you probably are having is like, what's a negative velocity, right? But we said that a negative velocity, at least in my class, is that a negative velocity would be when something's moving towards the detector. So remember, we had the detector out in the classroom and we moved away. That was positive velocity. When we moved back, that was negative velocity. And so the first 2 seconds, it's moving at a constant speed, right? Because it's moving at -5 at 0, -5 at 1, -5 at 2. So it's moving at a constant speed of -5 meters per second toward the detector. All right. So then we go here. Now, what do we see? Remember, always think in our head. I'm seeing -5 meters per second. Then I'm seeing -4, -3, -2, -1, and 0. I'm slowing down. Okay, even though I'm slowing down in the negative side, I'm still slowing down. And so I'm slowing down to get to where I'm at, like 7 seconds, I think that is. And then it says, what's the third part? We're stopped. Okay, so now we have 0 velocity. So 0 velocity means we're stopped. So always, always, always think in your head, like say it out loud. Like don't like just stare at the sheet, but actually say to yourself, what's -5 meters per second look like? Okay, so that's the first one. The second problem, it says determine the displacement from 2 to 7. So from 2 to 7, we have right here, there's 2, and then 7 is all the way over here. We have this triangle. And so when they say determine the displacement, remember that we said that the slope of a position versus a time graph means velocity. And the slope of a velocity versus time graph means acceleration. But the area of a velocity versus time graph equals distance, or in this case, displacement. We're using those two interchangeably. Some people got mad about that because they do mean different things, but when we're moving in a straight line, the distance and the displacement are the same. Okay, so I wrote down the equation right here. Distance equals area plus 1/2 base times height. And I drew over here the little triangle that's right here. It's a triangle from 2 to 7, and it's a triangle down with a height of -5. And so 1/2 base times height, 1/2 the base, which is 5, and the height -5, and so that total is -12.5 meters. Don't be worried about negatives and positives. The reality is that all that will wash out. All that means is we're moving in the negative direction. So we move -12.5 meters means we move 12.5 meters towards the detector. All right, number 3, determine the object's acceleration from 2 to 6. All right, so we have to remember our little cheat sheet of notes. What is acceleration? Well, acceleration is the slope of a velocity versus time graph. So here it says, in a velocity versus time graph, acceleration equals slope. We just need to find the slope of this line from 2 to 7. So I rewrote it right here. Here's the little line from 2 to 7. And what's the rise? Well, the rise is 5, +5. And then what's the run? +5. And so we have +5 divided by +5 equals a +1 meter per second squared. Okay, so that's the slope of this line right here, and the slope of that line is the acceleration. All right. All right, now we'll get a little bit faster now. So in the next paragraph, or the next set, we said here's the graph that shows the same object's motion in both a position, velocity, and acceleration graph. So first of all, like we were talking in my class, read those things. They're trying to tell you something. This is the same object's motion in the 3 different kinds of graphs that we've looked at. And so all 3 of these describe the same motion. And so when we going through this problems, then we can say in our minds which one makes sense to look at. So it says, during what time range does the object have the greatest positive acceleration? Well, if we're trying to find acceleration, we can definitely find it here. We can definitely find it here, but the easiest way to find it is in the acceleration graph, right? So we just have to read the graph. And so where is the greatest positive acceleration? Well, it's right here in the acceleration graph of +1. And so during the time range, during what time range does the object have the greatest positive acceleration? Well, from 6 to 10. Okay, from 6 to 10 seconds. And that makes sense, right? Because it's getting faster here, and we can see from the position versus time graph that's getting faster there. All right, so the second question is, what is the acceleration in that time range? So right there, 1, right? 1 meter per second squared. We're just going to say, look at the acceleration graph. All right, the next one, it says, at what time does the object move the fastest? So now we want to say, okay, what is fastest mean? Well, fastest means velocity, right? And so velocity would be the velocity graph. So we're going to look at the velocity graph, and we're going to look at, as soon as this thing goes crazy here, we'll move down here so you guys can see. Where's the fastest? Well, here it's moving pretty fast, but right here, right, is the fastest. So at 10 seconds, it's moving the fastest. And what's the velocity of that time? Well, we just look here, read the graph. Here it is 10. It's moving 4 at 10 seconds. So it's moving its fastest at 10 seconds. All right, and it's 4 meters per second at 10 seconds. And the last question on this is, what is the total displacement of the object? We have to remember, go back to our cheat sheet. We said on a position versus time graph, only thing that we got out of that is slope is velocity. But in a velocity versus time graph, slope is acceleration and area is displacement or distance. And so what they're asking us to do is find this displacement under these two triangles, under this triangle right here and under this triangle right here. So you can see in my thing, I say section 1, 1/2 the base times the height, or 1 times 4, and the height is 3, plus, and we go over here to section 2, 1/2 the base is 4 and the height is 4. So we have 6 plus 8, or 14. Okay. All right. Next question here is, we're giving this a velocity versus time graph. It says, given the written description, or give the written description. So what we need to remember, and so I drew a little picture up on the top there, is what is negative velocity and what is positive velocity. So negative velocity means it's moving towards the detector. So if we're going to describe this section 1 right here, well, that's -4 meters per second. What does that mean? How do we describe that in words? So the object moves at a constant speed, right? It's moving at -4, of -4 in the negative direction, or towards the detector. Okay, that one's the easy one. Now it gets a little bit harder. We need to understand that there's two sections here. There's this section right here of negative velocity, and this section here, number 3, of positive velocity. We're going to split those into two pieces. All right, so in the first section, then what's happening here? Well, we're going from -4 to 0. So when we go from a 4 to a 0, we must be slowing down. So we must have started all the way out here by the detector. We moved for 2 seconds at a constant speed, and now we're moving towards the detector and we're slowing down. Okay, so we want to picture ourselves. We're right here. That first section we move at a constant speed right here. Now we're going to still move towards the detector, but we're slowing down. And we get to a certain point right there. So this section 2, object still moving in the negative, but slowing down. Now what happens when we become positive? What happens to the velocity when we become positive? Well, it must be that the velocity turns around. The person turns around and starts moving away from the detector. So we have, during section 3 right here, it says object stops, okay, at 0, and then keeps getting faster, now in the positive direction. The object must have turned around and started going the other way. Okay, hard problem. Believe me, I understand. I kind of looked at it a couple times before I was willing to commit to my answer. All right, number 10, determine the displacement from 0 to 2. So from 0 to 2 right here, that's just this little square right here. And so what's the area of a square? Well, it's just base times height, or 2 times -4, or -8. So from 0 to 2, we have -8 meters. It says determine displacement from 2 to 4. Well, now we're looking at this little triangle right here. And so that's 1/2 the base times the height, or 1/2 2 times -4, and that's -4. So right there. And the last says determine displacement from 4 to 8. So from here to here. That's another triangle. 1/2 the base times the height, 1/2 4 times 8. So the base is 4, from 4 to 8, and the height is a total of 8. All right, we get 16. So we go to problem number 13 now, and it says determine the total displacement of the object. And now we see why this all makes sense. We said that our object started out way over here, moved towards the detector, turned around, and moved away. And now we can understand why we have negative displacement numbers, because it moved from here, -4, or -8, then it moved -4 over here, and then it turned around and moved 16. And so we can just add those numbers up, -8 plus -4 plus 16. The total displacement for this entire motion, it started somewhere over here, and it ended 4 meters further away. Okay, it went all the way over here first, and then went all the way right back here. But the numbers all work out so that we know exactly where it started from and where it finished. That's displacement, and it's only 4 meters from where it started. Okay, so it started here, moved this way, then moved back. Okay, last couple says determine the object's acceleration from 0 to 2 and show your work. So we need to go to a velocity versus time graph, and we know on a velocity versus time graph, if we want to find acceleration, we need to find slope. So the slope of the object from 0 to 2, the rise is 0 on here, right? It doesn't go up or down. And so the rise is 0, the time is 2, and so we've got a 0 acceleration. Makes sense, right? Because the object was going -4, after the time, still going -4, so it didn't get faster, it didn't get slower, acceleration is 0. All right, determine the object's acceleration from 2 to 8. Well, now we have to find the slope of this line. And we can do it in little bits and pieces, or we can do the whole thing. So I did the whole thing. I just said, okay, started right here. My rise is from -4 to 8. So the total rise is 12. All right, so the total rise is 12. And then the run is from 2 to 8. So from 2 to 8, the run is 6. So that's 6. And so I just 12 divided by 6, I get 2 meters per second squared. All right, final question, which is one thing that you want to be sure you remember when analyzing motion graphs. Look at what you're looking at. If it's a velocity versus time graph, think of the idea that we said in the bit that we can only get 2 things out of that. We can get slope is acceleration and area is distance or displacement. But if we look and we have a position versus time graph, well, the only thing we can find out of that one is slope equals velocity. Hopefully that helped you guys. I hope some of you guys actually watch this. See you later. Bye-bye.